What we are going to talk about today is solving a system by substitution. So in order to solve a system by substitution, you need to solve one equation in terms of the other, in terms of one variable, and then substitute it in. Let me explain to you what I mean. So this is called substitution. And for example, the first problem is 3x plus 4y equals 12. And the other equation is 2x plus y equals 10. Now, I could graph this on a line, on a graph, but the y-intercept for this equation would be positive 10. So that would be like way up high. And then this one would be positive 3. And it could just be a little bit tricky to graph it. It wouldn't be hard. We could do it, but there's another way to solve. When you solve a system of equations algebraically, meaning without a graph, you need to make one of the variables go away. We can't solve either of these equations and get an answer. If I solve it for y, I still have an x left in it, so it doesn't give me an answer for y, it just gives me the equation of a line. But watch what happens if I solve this equation for y. Remember, I subtract 2x from both sides. So now I know what y equals. I can plug it in for y in the other equation. I can substitute. So now I have 3x plus 4 times y, but instead of writing y, I'm going to write what it equals. And then keep writing equals 12. Now I just have a simple algebra 1 equation that I can solve for x. So I distribute the 4, combine like terms, 40 minus 12 is 28, is that right? I guess so. Divide by 5. So x equals 5.6. Now you can see how on a graph that would be kind of nasty, but that's the exact answer. But I said yesterday in class, when you have a system of equations, you are trying to find the point on the graph where the two lines cross. So you need an x and a y. Just the x doesn't help you. You have to have the whole point. So I'm going to take this x value of 5.6, this one right here, and I'm going to plug it back into one of these two equations for x. It doesn't matter which one. Oh boy, hey there. Doesn't matter which one. I'm going to take this one, the bottom one. So I'm going to go 2 times 5.6, because that's what x equals, plus y equals 10. Now I'm solving for y. 2 times 5.6 is 11.2. Solve for y, subtract 11.2 from both sides, and y equals negative 1.2. So the solution to this system of equations is 5.6 comma negative 1.2. And that's a coordinate, so it goes in parentheses. That means if I were to graph these 2 points on a line, I'm going to show you how to do that on a calculator. I'm going to check this on my TI-84 Plus here. The first equation was 3x plus 4y equals 12. In order to be able to type it in the calculator, I have to solve for y. I need it in y equals form. So let's do that. Solve this equation for y. I'm going to subtract 3x. Divide by 4. So negative 3/4 x plus 3. So in y equals, I'm going to put it in parentheses. Negative, I'm actually going to use my alpha y equals fraction because I like it. 3 divided by 4 x. So I didn't really need the parentheses because I used my fancy fraction button, plus 3. In the other equation, we solved it right here, negative 2x plus 10. And it says I have a syntax error, but I don't know what that would be. Let's go zoom 6. That's the line negative 3/4 x plus 3. And there's the line negative 2x plus 10. And if I go second, calc, intersect, choice 5, enter, 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 5.6, negative 1.2. So you can always check your answer on the calculator, but you have to know how to do it algebraically. Let's try another one. Okay. 3x plus 5y equals 13. 2x plus y equals 4. Now, you could solve this first equation for x and plug it in for this x. The problem is, if you solved for x, you would have two fractions. You would have 5/3 and 13/3. Anytime we can avoid a fraction, we want to do that. So, the rule of thumb is always solve for the variable with a coefficient. Always solve for the variable with a coefficient of 1. So the coefficient of this x is 3, the coefficient of this y is 5, the coefficient of this x is 2, the coefficient of this y is 1. So we are going to choose to solve for this equation for y. And all I have to do is subtract 2x from both sides. Okay, so that tells me what y equals. What does y equal? Y equals negative 2x plus 4. So I go to the other equation, and instead of y, I'm going to write negative 2x plus 4. So I go 3x plus 5. And again, instead of y, I'm going to write negative 2x plus 4 equals 13. And then we solve 3x minus 10x plus 20. This is a minus, this is a plus, equals 13. Negative 7x equals negative 7. X equals 1. But remember, I need a coordinate. All I have is the x value. I have to go back and find the y value. It doesn't matter where you plug this 1 in. You could plug it in here, or here, or here. To get the right answer, they all work. So I'll plug it in to this equation right here. So I'm going to go 2 times 1 plus y equals 4. 2 times 1 is 2 plus y equals 4. Minus 2 from both sides, and y equals 2. Now the nice part is this point should work for all three of these equations. So if I go 3 times 1, because x is 1, that's 3, plus 5 times 2 is 10, that should equal 13, and it does. And if I check it here, negative 2 times 1 is negative 2, plus 4 is positive 2. So it works for all of them. Let's try one more. Let's see. 2x minus 3y equals 6. X minus y equals negative 12. Now here, you don't want to solve for either of these because there's no coefficients of 1. This one has a coefficient of 1, and y has a coefficient of negative 1. Either one of those is fine. I'm going to solve for x. So if I solve for x, I'm going to add y to both sides, and I get y minus 12. So then I'm going to replace this x in the first equation with what it's equal to, which is y minus 12. Distribute 2y minus 24 minus 3y equals 6. Combine like terms, so I get negative y. Add 24 to both sides. Negative y equals 30, so y equals negative 30. And then we're going to plug that back in. I'll plug it into this one because that's the easiest one right now. So x equals negative 30 minus 12. X equals negative 42. Let's check that. Check it in the first equation. So if I go 2 times negative 42 minus 3 times negative 30 equals 6. All I did was take the x value that I found for an answer and put it in for x, and the y value and put it in for y. 2 times negative 42 is negative 84. Negative 3 times negative 30 is plus 90. And negative 84 plus 90 does equal 6. So it works. Check. We did that correctly. What else? That's pretty much all there is to know about substitution. You get one variable by itself, plug it in for the other variable. Sometimes, let me do one more example. Sometimes it's already done for you. For instance, look at this problem. 4x plus 2y equals 7 and y equals 5x. I already know what y equals. Y is 5x. So I can take out this y and put in 5x. So I go 4x plus 2 times y, but y is 5x in the other equation, equals 7. 4x plus 10x equals 7. 14x equals 7. X equals 1/2. And then don't forget to go back and solve for y, but I can just put my x right there, and y equals 5/2. 1/2, 5/2. System of equations. There you go.